How do you make a function table? You make a function table by following these steps. 1. Figure out how many x values you will use. 2. Draw up a table with 4 columns. Column 1 is for the x values. Column 2 for evaluating the function's expression. Column 3 for the y values. And the fourth and final column is for writing the coordinates x, y. The top row of the table will show the column names. You add one row for each x value. 3. Input each x value and evaluate the function to find the y value. Each pair of x and y values are coordinates of a point on the graph. By completing these steps, you'll have made a comprehensive function table. Now, in some situations, you'll come across function tables that show the x and y values only. But it's best to stick to the comprehensive tables in the beginning, while you're new to them. Let's examine how all this works through an example where you'll make a comprehensive table. Say you have the function f of x equals 3x minus 1. The first step is to choose x values. That way you know how many rows your table will have. You're going to create a function table using the x values of minus 4, minus 2, 0, 2, and 4. To start out, it is smart to choose both negative and positive values for x. Here we have 5 values, which means that your table needs 6 rows. The second step is to draw the table. For a comprehensive version of the function table, you'll need 4 columns as mentioned. One for the x values, another where you evaluate the function's expression, which was f of x equals 3x minus 1, one for the y values, and finally a column where you write the coordinates x, y. It is common to list the x values in ascending order like this. The third step is to input the x values and evaluate the function to find the y values. You do the calculations in the second column and write the y values in the third column. In the final column, you write the x and y values as coordinates. Let's start with x equals 4. That means you will evaluate the function at x equals minus 4 in column 2. You insert minus 4 into the function and get that f of minus 4 equals 3 times minus 4 minus 1. The answer is minus 13, which you then write in the y column. You then place the coordinates of the two values, minus 4, minus 13, in the final column. You continue like this for each x value. F of minus 2 equals 3 times minus 2 minus 1, which is minus 7, giving you the coordinates minus 2, minus 7. F of 0 is 3 times 0 minus 1, which equals minus 1, resulting in the coordinates 0, minus 1. F of 2 comes to 3 times 2 minus 1, equaling 5. So the coordinates are 2, 5. And finally, f of 4 equals 3 times 4 minus 1, which is 11. The final coordinates are 4, 11. Phew! Making a function table can seem like a lot of work. Luckily, it doesn't take too long once you get the hang of it. When you've become confident making function tables, you only need to list the x values and their corresponding y values. That means you only need to use 2 of the columns from the comprehensive function table. The first column with the x values, and the third column with the y values. You can think of this as a professional function table. So, the first and third columns are all that's needed. The pairs of x and y values are coordinates for points on the graph. How to draw a graph using these points is something you'll discover more about in upcoming videos. You make a function table by following these steps. 1. Figure out how many x values you will use. 2. Draw up a table with 4 columns. Column 1 is for the x values, column 2 for evaluating the function's expression, column 3 for the y values, and the fourth and final column is for writing the coordinates x, y. The top row of the table will show the column names. You then add one row for each x value. 3. Input each x value and evaluate the function to find the y value. Each pair of x and y values are coordinates of a point on the graph.